Hi aspirants, welcome to SRB's weekly roundup current affairs for science and tech and miscellaneous. Today's first topic is about the Pegasus spyware. It has been in news for a very long time and it has also created havoc even in the parliament. It is said that there has been many people's cell phones which has been spied using this Pegasus software. This Pegasus software is also called as the Q Suite. It is created by the NSO group or the Q Cyber Technologies, which is in Israel. Usually, how your mobile phone can be hacked. Some of the methods include enhanced social engineering message, simply called as ESEM. In this, an SMS or a WhatsApp message is sent to the target message to trick them to just click it. Once you click that message, a malicious software is installed in your system, in your mobile phone, which takes control of your mobile phone. Another method is network injection. In this method, it enables the attackers to install the spyware without requiring any interaction by the target. So there's no SMS sent, no message or nothing. Without any interaction, it can just install the spyware. One such option is the over the air or the OTA option. It is to send a push message covertly that makes the target device load the spyware with the target unaware of the installation. The target does not know there is a software or a spyware actually being installed behind the system. Pegasus is one such software. It can achieve zero-click installations. It uses various ways, and one such way is this over-the-air option. The target will not know a spyware is running behind in the system unless the device is scanned at a digital security lab. The next topic is about quantum communications. Quantum communication is one of the safest way of connecting two places or two devices with high levels of code and quantum cryptography that cannot be decrypted or broken by an external entity. If at all a hacker tries to crack the message, which is used in a quantum communication, it changes its form in such a manner that it would alert the sender. General conventional encryption lies on traditional mathematics, and for while now it is safe without hacking, so it can be used. We can use like antivirus softwares to help from hacking. We can use firewalls and so on. But the development of quantum computing threatens this because quantum computing is much more faster than the present computers, so it can easily crack the traditional methods of cryptography which we have been using now. Now, why this is in news? Because scientists from the Space Application Center and Physical Research Laboratory in Ahmedabad have successfully demonstrated quantum entanglement. So, in this process of encryption, using a real-time quantum key distribution or QKD, they conducted hack-proof communication between two places separated by 300 meters. And this QKD, it works using photons. The key here is a photon, which is a light carrying particle. It cannot be perfectly copied, and any attempt to measure it will disturb it. This means that a person trying to intercept the data will leave a trace there, and moreover, it will be alerted by the system to the sender as well. So it cannot be hacked, and moreover, it also shows that someone tried to even hack it. The quantum key distribution allows two distant users who do not share a long secret key initially, unlike the traditional system. A random string of secret bits called a secret key is used here, which is randomly generated each time. So that is why this quantum mechanics supported cryptography is much more safe. The next topic is Chandrayaan 3. We all know ISRO launched or India launched the Chandrayaan 2 program, in which it was a partial success. The lander alone did not land perfectly at the last moment, but the orbiter is still working much beyond its lifetime and it's giving lot of useful data. Now the Chandrayaan 3, it is a successor of Chandrayaan 2 mission and it will also likely attempt another soft landing on the lunar surface. We hopefully believe that this time the lander will land safely and it will create history. This Chandrayaan 3, it will only include a lander and a rover. It will not have an orbiter because the Chandrayaan 2's orbiter is already orbiting the moon and it is sending useful information. So this will not have an orbiter. It is just going to have a lander and a rover. And about the Chandrayaan 2, the Chandrayaan 2 mission, it had an orbiter, a lander and a rover with the goal of exploring the south pole of the moon. So what is so special about the south pole of the moon? It's because the lunar surface area in the south pole remains in shadow much larger than the north pole. And moreover, it is believed that there is presence of water in the south pole region. The mission has given most precise information about the presence of water molecules on the moon till date. Throughout the world, there has been many missions to the moon, but this Chandrayaan 2 has given the most precise information about water molecules on the moon. Apart from that, it has found traces of chromium, manganese, sodium for the first time through remote sensing. So this is what is special about Chandrayaan 2. It has given the most precise information about water and moreover using remote sensing it has for the first time identified chromium, manganese and sodium. The next topic is about the drone rules 2021. Nowadays we know drones have been used in various of fields, just starting from a wedding photography to dropping bombs on an enemy nation, delivering items by companies like Amazon and so on. And we also know until now drones have not been allowed for commercial purposes like delivery purposes like Amazon, Swiggy and so on. But already these companies have been requesting the Indian government for this particular purpose. Now, as on 31st December 2021, 9 remote pilot training organizations have been set up by entities of government and private ownership. This could be a prelims question whether a pilot training organization for drones can be set up by a private ownership organization. Yes, it can be done. And as per the drone rules of 2021, any person who intends to obtain the authorization to establish a remote pilot training organization, he have to submit an application to the Director General of Civil Aviation in the form of D5. So they have to submit a form called Form D5, which is available in the Digital Sky platform. So what are the new rules for the drones? There's no flight permission required up to 400 feet in the green zones and up to 200 feet in the area between 8 and 12 kilometers from the airport perimeter. And no pilot license is required for micro drones, which are used for non-commercial uses. And here commercial use does not come into the play. And for nano drones and for research and development organizations. And no restriction on drone operations by foreign owned companies registered in India. This point you have to note specifically that it could be a foreign owned company, but it has to be registered in India, else they might face some restrictions. And no requirement of certificate of airworthiness or a unique identification number and prior permission and remote pilot license for R&D entities. Only for R&D entities, these things such as airworthiness, unique identification number, prior permission and remote pilot license are not needed. Issuance of certificate of airworthiness now according to the new rules is delegated to the Quality Council of India and the certification entities authorized by this Quality Council of India. So getting a certification is going to be easier hereafter. Manufacturer may generate their drone's own unique identification number on the digital sky platform through the self-certification route. So this is just a self-certification route. So the process is made much easier here. And the maximum penalty under the drone rules 2021 has been reduced to rupees 1 lakh. And the most important factor here is drone corridors will be developed for cargo deliveries. So we can expect very soon that organizations such as Amazon, Swiggy, and such organizations are going to deliver their objects using drones. And the question here is, why do we actually need strict rules and regulations for drone usage? Recently, drones were used for the first time to drop explosive devices. And nowadays we know that drones are even capable of launching nuclear devices as well. And recently, the explosive devices were triggered blasts inside the Air Force Station's technical area in Jammu. So this is causing a serious threat, and that is why the rules are made, trying to be made much more stringent. Over the past 2 years, drones have been deployed regularly by Pakistani-based outfits to smuggle arms, ammunition, and drugs into Indian territory. And what are the categories of drones in India? Nano drones, which are less than or equal to 250 grams. Micro drones, which are 250 grams to 2 kilograms. Small drones 2 kgs to 25 kgs. Medium drones, which are 25 kgs to 150 kgs. And large drones are greater than 150 kgs. For example, they almost look like an aircraft. They are unmanned aerial vehicles. They've been used in air force and military purposes. And here registration is required for all the drones except for the nano category. We saw that for the micro category registration is not needed in case it's used for R&D purposes alone, but other than that, for every drone registration is compulsory except for a nano drone category. So the drones which we usually view in wedding photography and so on, they actually belong to this nano drones. The next one is again hydrogen fuel. We have already discussed a little about this hydrogen fuel in our 1 minute current affairs. But recently there is some news about this and we have to know that news as well, and we have to know certain more details about the hydrogen fuel. First, let us know some details, the basic details about hydrogen, because nowadays UPSC is known to ask general basic questions in science and tech. Here hydrogen is the lightest and the first element on the periodic table. Since the weight of hydrogen is less than air, it rises in the atmosphere and therefore it is very rarely found in its purest form, that is H2. At standard temperature and pressure, hydrogen is non-toxic, non-metallic, odorless, tasteless, colorless and highly combustible. So the two important points here are it is non-toxic and it is highly combustible. So that is why this fuel gains importance. It is highly combustible, which is the need of the hour, and at the same time it's non-toxic, which is even more the need of the hour at the time when we are making promises and we are having conventions for environmental safety. And molecular hydrogen is not available on earth in convenient natural resources. It is not so easy to extract hydrogen from the natural reservoirs, but at the same time H2 or hydrogen is the most abundant element in the universe. About 90% of the atoms in the universe are hydrogen atoms. Hydrogen is a component of more compounds than any other element. Water is the most abundant compound of hydrogen found on earth. And most of the hydrogen on earth is bonded to either oxygen in water or to carbon. So either it is bonded to water or to carbon. It can be created by splitting water into hydrogen and oxygen. This is the most familiarly used method to create oxygen. I'm sorry, hydrogen. And here, when it comes to hydrogen fuel, not just hydrogen, when it comes to hydrogen fuel, we categorize them into 5 different shades or colors. The first one is green hydrogen fuel. Here, the electricity from the renewable sources is used to electrolyze water and separate the hydrogen and oxygen. We know hydrogen is not readily available in its purest form. We just have water. We have to split it into hydrogen and oxygen. For this, we use a process called electrolysis. For this process of electrolysis, we need electricity. Now, how are we going to generate this electricity? If this energy is generated using a renewable resource, like a solar plant, like a wind turbine, in that case, it will be called as a green hydrogen. The next one is blue hydrogen. Here, the hydrogen fuel is produced using natural gas. Most of the greenhouse gas emissions are captured and stored. So here you are manufacturing electricity for the purpose of manufacturing hydrogen fuel. So in this first process, here you use natural gas to produce steam, and out of that steam you run the turbine and create electricity. Now this natural gas, when it is used, it will of course cause greenhouse gases, but it will be captured and stored properly. In such a way, if hydrogen fuel is created, it is called blue hydrogen. The third one is turquoise. Turquoise almost like a green and blue mixed color, somewhat like a green color it is. Here the natural gas is used, but by a process called pyrolysis, by separating methane into hydrogen and solid carbon dioxide. Here the method is completely different. Here you don't use water to split it into hydrogen and oxygen, but instead you directly take natural gas. So natural gas is something like CH4, something like that. So you take methane and you split methane into hydrogen and carbon. So we have CH4, which is methane. So when you split carbon and hydrogen from this methane, you get one carbon atom and 4 hydrogen atoms. So this is, if in this method, if hydrogen fuel is manufactured, then it is called as turquoise shade of hydrogen. The next one is gray hydrogen. This is the one which mostly used or manufactured nowadays. For example, the new plant that India has installed recently uses gray hydrogen, and they are trying to go to green hydrogen very soon from there. Here the hydrogen is produced using natural gas via steam formation, but with no carbon capture and storage. Here you can, if you can compare and have a look at it, blue hydrogen and green hydrogen are almost the same. In both the places natural gas is used, yes, but in the blue hydrogen the greenhouse gases emitted are captured and stored properly. But in the case of gray hydrogen, that process, which is too costly, is not done here, but just the greenhouse gases are let into air. In that case, it will be called as gray hydrogen. The next one is brown hydrogen. Here hydrogen is produced using coal instead of natural gas. This is the worst one here for the environment, of course, but with no carbon capture and storage. This remains the cheapest form. So you don't need natural gas, simply use coal, and that too you don't go for carbon sequestration. You don't capture carbon, you don't store carbon, you just let it into air. So that is called as brown hydrogen. Mostly this is never manufactured, because going for hydrogen fuel by burning coal and not even doing sequestration for that, it's as same as just using coal as a fuel. It's useless. So now why we talking about this hydrogen fuel? Because it's in news. GAIL has started India's first project of mixing hydrogen into the natural gas system of blending hydrogen in city gas distribution network. We know in some cities in India, they have started to give piped gas for home use, for domestic use. In this, they are trying to mix hydrogen with the natural gas system. This project is initiated in Indore in Madhya Pradesh. This could be a question for you. And GAIL has started with grey hydrogen. As I already told you, they have just started with grey hydrogen now, which means they are going to use natural gas to produce electricity, use that electricity to go for the process of electrolysis to split hydrogen and oxygen to get hydrogen. So this is called grey hydrogen. Here, will the greenhouse gas that is released be captured and stored? No. In that case, it is called as grey hydrogen. and it will be also used for compressed natural gas or CNG for automobiles and piped natural gas to households in indoor. And the government is planning to blend 15 percentage of green hydrogen with piped natural gas for domestic, commercial and industrial consumption. So this is the target. Now they are just using gray hydrogen, and very soon they have planned to go to green hydrogen, and then the target is they are going to fix 15 percentage of green hydrogen with PNG. And this has been asked in sometimes in certain test papers in match the following. PNG is used for household purposes and CNG is used for vehicle purposes, automobile purposes. So this also you have to know. And what are the benefits of blending hydrogen with the natural gas? Either you can use natural gas separately or you can just use hydrogen as a fuel, isn't so? You can just use hydrogen fuel. We already have hydrogen cell as well. Here the concept is completely different, where you are mixing hydrogen and natural gas. So what are some of the benefits? It is easier and safer to use hydrogen mixed with the natural gas than directly using hydrogen, because this mixture contains very low energy content from hydrogen, up to 30 percentage by volume. And the next one, hydrogen enriched compressed natural gas, that is HCNG. So we know CNG, but here it is HCNG. It will ensure 70% more reduction in carbon monoxide emissions compared to CNG, because now at present completely switching over to hydrogen fuel, it's not so easy because we are nascent in that technology. At the same time, we are already using CNG, but when we can mix CNG with hydrogen, and when there could be 70% reduction in carbon monoxide emissions, it's really great to do, isn't it? Next one, power output of this HCNG is also better than CNG fuel. And blending integrate concentrations of hydrogen into existing natural gas pipelines and reduces carbon intensity of methane. So when the hydrogen content increases and carbon intensity of the methane decreases, because natural gas is made of carbon and hydrogen, CH4. So when you blend hydrogen to it, it reduces the intensity of the carbon there, but it increases the intensity of hydrogen, which means again less pollution. And moreover, as India has committed to achieve net zero carbon emissions by 2070, I hope you know, India gave this promise in the Glasgow summit last year. So to achieve that, we have to do all such things. And moreover, the government is looking to raise the share of natural gas in the primary energy basket to 15 percentage by 2030 from the current 6.2 percentage. Now we are using natural gas only 6.2 percentage. Rest is direct petrol, diesel, kerosene and so on. Now we are trying to increase it to 15 percentage by the year 2030. And this process, where the blending of hydrogen and CNG, this plant which is started now in Indore, it is under the National Hydrogen Mission. The National Hydrogen Mission, it was announced actually in the 2020-21 budget, not in the 2021-22 budget, because if in this prelims, if this question is asked, most probably we can fall. We would choose it as 2021-22 budget, but this is the last budget where 2020 to 21 budget in which this National Hydrogen Mission was announced. So now what are the challenges for us? Why we are struggling with hydrogen fuel? The technology is very nascent. We are at the starting stage. The technology used in production and use of hydrogen, like carbon capture, storage and hydrogen fuel cell, all are nascent technology. When you produce hydrogen, you have to produce a hydrogen fuel cell, and that technology is at the nascent stage. And moreover, on the process of manufacturing hydrogen, we have to use some other fuel. In that case, you have to capture hydrogen, you have to capture the carbon and also store it. Simply the word is called as carbon sequestration, and this also is a nascent technology. But at the same time, storage is also an issue. Hydrogen can be stored physically as gas or a liquid, both. If hydrogen has to be stored as a gas, It requires typical high pressure tanks which are very unique. And storage of hydrogen as a liquid, it requires cryogenic temperatures. To maintain the cryogenic temperatures, you have to spend a lot of energy again, because the boiling point of hydrogen at just 1 atmospheric pressure is minus 252.8 degrees Celsius. Just think, it always keeps boiling. In normal room temperature, it just keeps boiling. You have to keep it in cryogenic temperatures to keep it just normal. And hydrogen can also be stored on the surfaces of solids, and this process is called as adsorption. It could be an important question, note it down. If you store hydrogen on the surface of solids, it is called as adsorption, and if you store it within the solids, inside the solid, it is called absorption. So it's adsorption or absorption, both are there. You have to know the difference between both. But in spite of all, if we could somehow achieve all this, there are a lot of benefits as well. One thing, a hydrogen fuel cell, when used in an electric motor, in an electric car, let us say, it is 2 to 3 times more efficient than a normal internal combustion engine which runs on petrol. The next one, the energy in 1 kilogram of hydrogen gas, it contains the same amount of energy in 2.8 kilograms of petrol. It's almost 1 is to 3. 1 kilogram of hydrogen is equal to almost 3 kilograms of petrol. So energy efficiency is going to be really high. The next topic is about coal gasification and liquefaction. Again, we are going to talk about one another technology to attain self-sufficiency in energy or fuel anyway, and try and reduce environmental impact because of that. So one was, we are trying with solar energy, we are trying wind energy, we are trying with hydrogen cell as well, and the other one is coal gasification and liquefaction. So this is in news now because the central government has said 4 coal gasification plants will be set up on pilot basis to understand the technical and financial viability of such projects. So this one, noted down, this is not that project, we are just testing it. By starting 4 coal gasification plants, we are going to test whether it is viable. If it's viable, it could be expanded. So now what is coal gasification? Simply gasify the coal. We know coal is present under the soil. We dig the soil and take out the coal and burn it. But instead of doing that, let the coal just be there. Just to do something, directly convert it into gas or directly convert it into liquid and take it out and use it. That's it. Here you can see that you use some sort of oxidizer. You use oxygen. Along with water, you send it to the coal. From there, once that coal there is oxidized, it gets converted into syngas. Once the syngas is generated, from there you synthesize it, you harvest it, bring it up to the ground, and then you separate it and you use it for producing electricity. That's it. So coal gasification is the process of producing syngas, or the full word is synthetic gas, which is a mixture consisting of carbon monoxide, hydrogen, carbon dioxide, natural gas, that is CH4, and of course water vapor. Because the water that you send in will come out as water vapor, that's it. So this could be a potential prelims question. Note these chemicals down. So syngas is a mixture of carbon monoxide, carbon dioxide, hydrogen, natural gas, and water vapor. So how the process happens? Coal is blown with oxygen and steam, and it will also be heated under high pressure. So pressure is given, oxygen is given, steam is given. So during this reaction, oxygen and water molecules oxidize the coal and produce this syngas. Now this coal gas, why we have to try and manufacture this? Because it has greater efficiency than just burning the coal, because it can effectively use the gas twice. So once you get this coal gas, you can use it twice. The coal gases are first fired in a turbine, because it's coming out as a hot gas. You can just fire it into the turbine to generate electricity. and the heat that comes out of the exhaust, you can capture this heat, and that can be used to boil water, and that boiling water will produce steam, and that steam can again used to run the turbine. So you can produce electricity twice using the method once, that is using just once the coal gas you can produce electricity twice. And now, what is coal liquefaction? It is also called coal to liquid technology or CTL technology. It is an alternative route to produce diesel or gas. We know how is petrol or diesel created. Some lakhs of years ago, thousands of years ago, all these dead organic products which have got stuck under the soil due to the sedimentation of the soil, they get stuck underneath because of the pressure and because of the heat. All the excess substances are squeezed out, and only the carbon stays there. Just the carbon stays there, sometimes along with hydrogen. If it stays along with hydrogen, it becomes natural gas. If just mostly it is carbon that is staying there separately, it gets hardened, it looks like a stone, and it becomes as a coal. So coal and at the same time, if the pieces are not big trees, if they are like small plants and dead animals, they are also carbon products, the same product again. But since it's not very hard, it gets squeezed up and it becomes diesel, or I'm sorry, it becomes just crude oil, it becomes oil, that's it. So the coal and the oil both have the same composition, so it can be shifted from one to another. So here coal liquefaction technology is, it's an alternative route to produce diesel and gasoline. Direct, we produce gas, we produce gasoline, we produce petrol, we produce diesel. The process involves gasification of coal, which in turn of course will produce a synthetic gas. We know already what is syngas. Now this syngas can be liquefied to its fuel equivalent in presence of cobalt or iron as the catalyst. So the important point here is, what is the catalyst used to convert syngas to petrol or diesel? It is iron or cobalt at high pressure and temperature. So at the presence of high pressure and temperature, using cobalt and iron as a catalyst, you can convert syngas into petrol or diesel. But the problem here is, liquefied coal emits twice as much as carbon dioxide than oil, because it is carbon here, it is completely carbon here. So it will emit more carbon dioxide, and it also emit large amount of sulfur dioxide. It emits lot of carbon dioxide, almost twice which is emitted by petrol or diesel, and moreover large amount of sulfur dioxide as well. So can this coal to liquid technology not used at all? No, not at all. There's a solution for this. The carbon dioxide emissions are more readily and cheaply captured from these CTL plants than from the conventional coal-fired power stations. So most of the power stations now we are using, almost 70% of electricity that we produce here are from thermal power plants, that is using coal. But here, to capture that carbon and to store it, that is to do carbon sequestration, is a difficult process there. But at the same time, here in the case of this liquid coal, capturing the carbon and storing it is very easier and cheaper. Now in this case, we can know that though it emits more carbon dioxide, though it emits more sulfur dioxide, let it emit, what's the problem? It's easily and cheaply available that we can capture it and store it. Carbon sequestration can be done very easily. So in that case, which is better, whether it's directly burning carbon or coal liquefaction? Definitely it is coal liquefaction. And that's it for today. Thank you. If you found the content useful, share it to your friends as well. Let us learn and grow together. Jai Hind.